just like to thank you all for coming to the second to last session of SOLIDWORKS World and for being awake after last night's party. We're going to go ahead and talk about automating SOLIDWORKS. I'm Ethan Kinney. I work as a CAD administrator for a linear motion company. A little bit about myself. I've been using SOLIDWORKS for about 8 years now. I'm a self-taught programmer. I use Google, YouTube to figure out all of this stuff. I'm more just a CAD administrator, programmer in that sense. So the goal here, I more or less want to get you interested in using the API, in automating SOLIDWORKS, make your lives easier, do a little bit less repetitive tasks. I really want to show you basically how to make your work easier, make your lives easier. Maybe if you're the CAD administrator, make your users' lives easier, and maybe just open up a few doors. But more or less, I want to change you from asking the question of what are the limits of SOLIDWORKS to what can I actually make SOLIDWORKS do for me. I'm not really going to go in depth with any of the code. We'll just be kind of talking a little bit high level what's going on. But I will be explaining more or less the theories behind some of them and how they can build upon each other to fully automate SOLIDWORKS. So this is pretty much my mantra on why I program. I hate repetitive tasks. I hate hitting the same mouse button 20 times in a row. So I'll write a program for it. It might take me an hour, might take me 2 days to finish it. A lot of times I end up like this though. I end up trying to come up with some sort of complex algorithm to take care of something that really I only have to do that task once a quarter. So it's just a little bit of a waste of time, but it's a lot of fun figuring out that stuff. All right. So some of you may or may not know what the API is for SOLIDWORKS. So the API is the application programming interface. It's more or less an exposed set of subroutines that SOLIDWORKS gives to you. So instead of having to click the extrude command, you could do the extrude command through the API. And there's hundreds and thousands of functions available through the API, not only for SOLIDWORKS, but you can do the PDM, you could do simulation, you could do costing, pretty much any aspects of SOLIDWORKS or its different programs you can control via the API. So I'm just going to go ahead and show you guys some examples of using the SOLIDWORKS API. We're going to start out kind of small, some simple things that you could do yourself. We're going to just do some quick tolerancing, things like that, and then we're going to work into more complex things, and these can all build upon each other. So I'm going to switch over to SOLIDWORKS. You can all see it. All right. So the first one, we're going to just talk about quick tolerancing. I just got one of the template prints, tutorial prints up on here. Right now, it's all in metric. My company, unfortunately, works completely in inch. So I'm going to go ahead and convert it all to inch for me. Now, my company likes to do a lot of limit dimensions. So I've actually set up this program to where you need plus or minus 1 thou. You just select the dimensions, click what you need. These over here say I need plus or minus 5 thou. I can do that. If I really want to, I could give it a custom tolerance. I could go 0.0001, give it a tenth, give it a negative tenth. And then I want it to actually show 4 decimal places here. And then I've got that there. It's just a quick way for us to do the dimensioning that we're normal to, as opposed to having to do a few extra button clicks. It just more or less speeds up our lives, helps that. All right. So the second one, it's a pretty basic one, and you may be wondering why I even did it. Sometimes I actually run into this issue with other products or other parts, but you see I've got that hole up there. Let me actually go ahead and close this out. If I go into any of these other configurations, that hole's not in there. I need to unsuppress it via that feature there. So let me go ahead and relaunch that. What I can actually do is go ahead and click on this hole here. I'll set it up to go ahead, unsuppress in every configuration. The code behind the scenes, basically what it's doing is it's taking that feature and it's setting a flag on there to be unsuppressed in all configurations. So if I go ahead and go into those same configurations I was just in, it'll be unsuppressed in all of them. So this macro actually works not only for the features, but it works for sketches, it works for components, pretty much across the whole spectrum of SOLIDWORKS there. So it's another pretty simple one, not too much to it, not very many lines of code. Now this one, I wrote this more or less just because I'm anal about having the same note on every page, meaning the same exact location on every single page. So if I go ahead and go to one of these other sheets, I don't have that top level note there. So I go ahead and click on it. What I'm going to do is go ahead and pull in all the information I need about that note. What the text actually is, what the name of it is, where it's located, what sheet, what the text angle, rotation, that stuff is. And I can actually hit this copy to every sheet, and it'll take that info, copy it, same exact location, same exact formatting on every single sheet. But what I could do is if I go back and I drag this over here, I'm going to re-get the position, but I'm going to actually change it to be a different note. I'm going to say, yeah, I actually want it to be 45 degrees. I actually only want it to be on sheet 7 here. So I'll copy it to this one, or I want it on sheet 10, I'll copy it to this one. It's just a way to take some of that styling that you would be doing manually and kind of going back and forth to make sure it's in the right place if you're that kind of person, and automates it that way. All right. So how many of you have ever run into dangling dimensions and having to go through your sheets and delete them? So there's a really simple routine that you can write that actually iterates through all the dimensions on a sheet, and it'll go ahead and find those ones, get rid of them, just makes your life a little bit easier. Again, it's something simple, but you can build upon it by taking this macro along with a bunch of other ones and building a super macro, more or less. This one, it's similar, but I've got a few overridden dimensions on here. I don't know if any of you have run into having new engineers in your company going, I'll just override that dimension. No one's ever going to notice. Well, you could write a routine like this, and hey, I see those overridden dimensions you just did. Go ahead and fix those. So you can see I've got them highlighted red. It's very similar to the delete dangling dimensions, only in this case, it's looking for a flag that says overridden. And when it finds that flag, it changes the layer that it's on to give it that red text. All right, this one's a little bit more complicated. I actually use this one quite a bit for my company because we have a few subdivisions. And a lot of times I have to switch back and forth between the different sheet formats depending on the size I need or the company I'm working for. Here I've got the sample template up here, but say I need it to be A size or I need it to be B size. Or if I'm working on a secondary sheet here, I need this to show the secondary sheet template format. And it's just, these are preset options for us. We could go through the right-click edit sheet format, choose what we want, put it in that way. It's just a lot of extra button clicks, and I don't want my users spending that time. I'd much rather them just go ahead and click what they need really quick. And actually, this way I can control to make sure they have the latest and the greatest template, and they're not using something from 5 years ago, 10 years ago, something before my time. It doesn't have the information with it. I could even set it up to do a range of values and say I want everything from sheet 0 to sheet 4 because I work at sheet 0 as opposed to sheet 1. I could say everything needs to be the B size. It'll just iterate through all the drawings and do it that way. So again, it just automates the life a little bit, just a little bit less frustration. All right, this one would be more or less for a marketing department. Say we've got a full directory of drawings, a full directory of prints or models, and I just need to quickly give them a print of everything. I don't know if you've stayed there for about an hour having to open, change the print settings, go ahead and print it, close it out, go to the next one, open it up. Wait, did I already print this one? So instead you could have a routine like this. You go ahead and set it to the directory you want. It'll iterate through every file type in there that you want it to. It'll go ahead, open it up, take a snapshot of it, reorient it to where you want, take the snapshot, save it out as a PDF or a JPEG, whatever you need. And I've got it set up to where it'll go ahead and just open it up, and I've got all of those parts there. Never used PDF on here apparently. So another thing that it just automates, and I could utilize it with one of those previous routines to go ahead. I want to clean it up, or I want to actually set it to where all of these prints coming out are using our newest industry format, our newest templates. Say we just got acquired and we have to give them all the prints of the new company with their new template. Well, I could combine this one with the previous one. So more or less just kind of building blocks and making more and more complicated macros. This one I didn't actually write. This one you can actually find online on the community forums. Basically, I just have a layout here from the tutorials, and I want a bounding box sketch around it. Say I need this information just for the envelope of what it's going to fit into, get all the parts, be able to get that info. But I did go ahead and modify this. And the reason I modified it is for a more complex macro. So now it'll draw the bounding box, but I've got these planes set up that I have linked to a drawing. That way I can get all that drawing information onto the template, say, this is configurable part, and I'm putting in a bunch of different parts. I want to show what the envelope is on the drawing, so I set up the drawing format to link dimensions between the planes. So now if I go ahead and I've got this set up right here, I've got the bounding box, and I got the bounding planes all around it, I can go ahead and move this off to the side, move this down, redraw it, and I have all that information. The drawing would be updated. I would be good to go. So again, just building more upon the others and making it more complex. So this one's a bit of a special macro. What I have here is just a print based on that previous drawing. I've got it set up the way I want it, and this is going to be my template for future configurations, things I want to do. So I've got all my dimensions set where I want. I've got my view scale set up where I want. I never want this to change. So what I could do is take a snapshot of what sheet is that drawing view on, what are the bounds of it, the coordinates of it that I want it to match to. I could do the same thing for all the annotations. This is where this annotation belongs. Or I can go ahead and get both of it. Now, the reason I'm doing this is if it's a configurable part, or in my case, a fully automated system, I need to put everything back onto the sheet. So in this next one, I'll be able to import that info. So here, say I move off the dimension, move that over there. Sometimes you get that, you change configuration, everything blows up. But I could go this, and it'll just go ahead and import those right back into where it belonged before. And even more so if I go ahead and open up this assembly, and I start to move things around and really mess with what it can do, really configure it the way I want, and I go back, you can see everything's screwed up now. I'm going to have to spend a half hour fixing this. Or if I took a snapshot of where everything should be, it reformats it, I'm good to go. I spent almost no extra time there. This is, for me, how I get to a fully automated system. Now, this last one, it was more or less a proof of concept that I could do it. So I went ahead and made Snake in SOLIDWORKS. So I've got it set up. It'll go ahead and create the entire game board for me, create all the pieces, set up the rules and everything. So if I go ahead and start the game, I can play Snake. So you can really do whatever you want in SOLIDWORKS. There's kind of no limitation to what you can do in it. So if I wanted to, I could have a company-wide game of Snake. Really, it's limitless to what you can do. And if you guys want the source code later, I'd be more than happy to share it with you. All right. I apologize. This is going to be a short presentation. I don't have that much. I just want to get you to enjoy it and to like it, to go play with it and try it. We'll skip all the backup videos because the presentation actually worked. So if you want some resources, where to go and where to start this, first of all, look on the SOLIDWORKS API help. They have all the info there that you could need. They have every subroutine that's available. There are a few subroutines that aren't shown on there that you can get access to, but they work sometimes, they sometimes don't work. It lists VBA, which is the natural editor inside of SOLIDWORKS. You could do VB.NET or you could do C#. The SOLIDWORKS forum is a great place to look to. These guys are experts. They will answer your questions in just a matter of a couple of hours. Some of them might be here at SOLIDWORKS this year. I know Keith Rice is doing a presentation next hour, so if you get a chance, meet some of these guys. If you have API questions, you're probably get an answer from one of these guys. You can go to mysolidworks.com, or my favorite way, I just Google it. It seems to work pretty well, just SOLIDWORKS API, whatever I need to do. Usually I put in the command there, something I'm working with. Stack Overflow Code Project, those are pretty good resources for just the general programming. not necessarily SOLIDWORKS oriented. And if you're really wanting to start basic, just start up the recorder, run through what you want to do, and take a look at what the code is. Generally speaking, you're not going to take that code as is, put it into production environment, because you're going to need to modify it, make it do exactly what you need it to do. All right, so this presentation is on automating SOLIDWORKS, total automation. So one of my job functions is I create configurators for my company. More or less, we want a customer to go online, and as opposed to sending in, I need this part, which you've never made before, so we're going to send it over to the engineer to come up with the new prints. Instead, I'll send them online, and they can go ahead and say, I want this compact series here. So the user is going to go ahead and click on that, start the configuration process. I will say the interface you see here, this was purchased, we purchased this from Infor. Certainly you could do DriveWorks, something of that nature too. Really, it doesn't kind of matter which configuration option you're going with. So here I'm just going through selecting some different options. I want it to be an actuator that's about 400 millimeters long with a few different options involved in it. I'm going to go ahead, I put in my email information. I'll go ahead and submit this configuration. Now what's going on in the background is it's taking all that data and it's sending it to a remote SOLIDWORKS server. That server is going to go ahead and start processing all the CAD. In a second here, we'll go ahead and flip and take a look at what it's actually doing. So this whole system is set up as first in, first out. So as soon as it gets information in from the customer, it starts processing. So we're using a box machine to run this. It's a really fast machine, so it takes it almost no time at all to go through it. But we're not just creating the CAD model for the customer, we're creating the CAD model for internal use. So right now I'm running through it and just removing the components I don't need, adding the components I do need, changing the dimensions I need. But not only that, I'm going to also go ahead and start exporting all of this to the different CAD formats that I need to offer to the customer. So I'm going to export the step, the IGIS, just a simple part file, all of that information that the customer might want. Certainly I could ask them ahead of time, well, do you want a step? And I could only produce the step file for them. So right now I'm going to go through and you can see it's already converted it over just to a SOLIDWORKS part file as opposed to the assembly. So we're protecting a little bit of our intellectual property that way. But when it finishes rendering all the different file types, it's going to start creating our production prints for us. So it's going to go through here. We've got the lead screw in it that we custom machine. So it's going to reposition everything according to the new location or to that template. So what you saw earlier, this is actually what we're using it for. You'll see some triangles start showing up on there. That's for our inspection notes, and we create the inspection documents to go with it all. We do the first article inspection throughout everything. You'll set up all the tolerances. We have different tolerances based on what the customer chooses. It gets the bill of material all set up for the customer. You can see there it just threw everything away, but it's going to go ahead and reformat and bring everything back in position of where it needs to do. Occasionally you get a dangling dimension in there because, well, you dimensioned it to this geometry, but they choose not to have that part. So my routine will go through, delete out all of those features that they don't want, and it'll give them a finished print at the end. You saw it auto-ballooned it right there. So that'll be for the production print of how they actually put it together. So literally, it'll do everything for us. And then beyond that, we'll get it set up to where it integrates into our ERP system and does some of that automation. So at this point, it's done processing. That took, about a minute, minute and a half to do so. The customer has access to all this information. On the back end, I have access to the production prints, all the information I need to actually go out and produce it. Now, why would you actually want to do this? Well, here's a little bit more information on that. So yeah, I'm using Infor configure price quote for this. You could use DriveWorks. I think there's a few configurators out on the partner pavilion. It really doesn't matter what you're using because you can extend them beyond just what their capabilities are. So for CPQ, it's pretty good. It creates the assembly, creates the dimensions, adds the components, creates the drawings, and changes some of the properties. But it doesn't change the tolerances. It doesn't change the configurations. It doesn't run custom macros. doesn't update the text in notes, doesn't auto-explode and auto-balloon things for me. But you might be thinking, well, we just saw all of that. But that's why I've been writing all these custom programs. I've got 27 specific programs for this that I've written using the SOLIDWORKS API to extend it to make it do exactly what a design engineer would do, what an engineer would need, all of the production information. That stuff doesn't come canned with a lot of these packages. You'll have to go through and extend them to get that functionality. So now I can go ahead and change the tolerances. I can run my custom macros. I can explode it. I can create my inspection reports, do all of that information. And this is really important because you can really start to take all of these little bits and pieces, this tribal knowledge from your company, and bring it all into one place and really increase the time. For instance, what you saw there would usually take one of our engineers at least 3 hours to do, just with the drawing itself, not including all of the clerical work they have to do with it too. So now it's about 5 minutes worth of work. And if the customer doesn't like it, they run it again. Great thing about that is we haven't wasted any of our time. So it reduces our errors too. One of our products, there's about 64,000 combinations of little bearing that we produce. We had about 500 or 600 unique drawings out in the system, ranging all the way back to the 90s, just because they were TIFF files that were scanned into the system. And we were still making them from these old TIFF files. So we went ahead, brought on all that information into one massive spreadsheet that runs our back-end production process. The spreadsheet contains 30,000 cells worth of data, all the dimensions, all the tolerances. But now we can get a brand new print for a bearing we've never made before in a matter of about 30 seconds. And then we can be off running. And then somebody doesn't have to do any of that. So for us, it just makes sense. It makes everything easier. We have more time now to develop our new products. So for me, that's my presentation. Do any of you have questions? I have run into those before. His question was, well, did you have more to that? Sorry. All right, so his question was, occasionally if he's running the macros, he'll get the error message that says, your system is now in an unstable state. And as soon as you hit the OK, it crashes. For me, one of the issues I've run into is if you're running an automated solution, after a couple runs through the process, your GDI objects are going to start to grow. GDI objects are, I'm not entirely sure what they are. It's a holdover for Microsoft, and there's about a limit of 9,000 for those of you fans out there. But once you start to reach that threshold, SolidWorks is going to get a little bit unstable. So I have a routine set up using the task scheduler that every night at midnight, it actually restarts SolidWorks. That way it just goes ahead and clears out that cache, and I get a fresh copy of it. That's kind of the best solution I came up with. I say that a little louder. All right, just tell me when to stop. That one? Okay. Anything else? So the question was, any preference versus VB and C#? I found actually if you're writing macros in SolidWorks using VBA, sometimes they tend to run a lot faster than if you have an external program, VB.NET or C#. Either of those two languages, they seem to compile to the same code. So I really have no preference between either VB.NET or C#. But if I have a process that's going to be iterating through dimensions, iterating through features, it's a whole lot faster to write that in VBA, even though sometimes I don't like to use VBA. There just aren't as many tools there. It processes maybe sometimes 10 times faster than it would if it's an external program. And it's just because it's an in-process macro as opposed to an out-of-process program communicating back and forth with SOLIDWORks. Yeah, so the question was, what was that? No, so his question was, I'll try and say it properly. CPQ was running the interface that the user was interacting with. All of those rules, that was the canned program that we got. When we got into the SOLIDWORks, it'll create the models usually without a problem. All those rules are native to it. It works pretty well. It's when we started to get into we want to take this to the production environment and really have production level prints that we started to create all these external programs. But the system will actually run those as it goes. You'll just put a call to the external program that you need inside of the system. So I can tell it, I want you to run this custom SOLIDWORks macro here and do whatever you need to do. Yeah, and when I was developing all those macros, I could actually run those on the sheet, see and make sure that they work, and then all I had to do is basically create a call in the main program to call that particular macro. So for development time, to get it to the point that it is, since I really have no formal schooling in all the programming, it was a lot of self-taught, figuring out how this worked. I spent probably the better half of a year playing around, doing different things, figuring out what works, what doesn't work. A lot of times I would have a macro that works okay, it seems to function, but then the requirement came up is that's too slow, it's got to go faster. So I would take the idea, I would scrap out all the code, and I'd rebuild it with some of the information I learned a little bit later on. So it was a lot of recursive development, just going back and making the code faster and faster and faster. Well, the whole goal was it was me at the forefront of figuring out how to do all this, and then we train more people, but that never seems to work in the real world. So right now it is still me developing all of this, but hopefully by the end of the year we'll have our current product offering all of the products into this configurator system. At this point, I don't really need to write any more custom programs. It does everything we need to do, and we've proved it out on a few of our products. Now it's going through and just gathering all the information, the tribal knowledge, putting it into the system, pushing it forward. So now we're able to actually crank out one of these configurators about every 2 to 3 weeks, not including all the validation that goes with it. So, I think you had a question?
How are you referencing specific dimensions in views? Are you doing that by name?
I am. Repeat the question a little bit.
How are you referencing those, like a specific dimension or a specific call out so you can do it?
Gotcha. All right, so the question was, how am I referencing the particular dimensions and things like that? Every dimension and pretty much anything that you click on inside of SOLIDWORks that'll highlight has a unique name associated with it. If you're working within a part or within an assembly, you can actually change that name. If you're inside a drawing, it doesn't natively come up to say, hey, you can change this from being D1 to be D2. That was another program that I wrote that I didn't show here. I can click on any dimension in a drawing, and I can pull up what the name of it is and override it to make it something as opposed to being detail item number 563, because that makes no sense to me. I can call it finish bore or rough bore or something like that, and I can pull in that info. One other way you could do that is if you start the macro recorder and you click on dimension or a drawing view and hit stop, and you go into the code that it created, it'll tell you exactly what the dimension is. And you can pull it up that way.
You mentioned that on the slide it showed that your source code would be available. Where would we go if we wanted to look at that?
All right. If you go to that website right there, I'll have all the demos available, and they're all VBA, so you should be able to download the zip file, play with it all you want. I may have made a few updates, so I'll probably be uploading that either tonight or sometime next week. But it should have all the source code in there. It's got all the files that you would need to run it. What was the product? With MBD? I wanted to. As far as I know, they haven't released that API yet. I'm waiting for it, though. As soon as they do, I want to try and convince my company to switch over to that and get away from the drawing rules. I think the MBD API would be a whole lot easier to use. You find, so his question was, if I have a really large assembly and I want to use that, open it up and print it out and go on to the next one, the opening times take a lot longer. The best advice I would have there is find a colleague who's on vacation and just use their computer. So, and there's really no way to utilize SOLIDWORKS if you're running some of these automated routines. Maybe set it up before you leave for the day, or before you go to lunch if it's a long routine. I've got a routine that'll actually automate that configuration process for us so we can create 10, 20, 100 different prints and then validate them. And I'll actually set that up to run before I leave for the day. And it'll just process through all of them. So, any other questions? All right, well, thank you for coming. Enjoy the rest of SOLIDWORKS World.